Hey everyone, Matt here with Nightrun Studio. Up until now, we've been setting up some basic states with our enemy. So we have this player detected state when the player gets close, or when we leave the enemy's aggro range, he goes into a patrol state. In this video though, we're gonna set things up just a little better organized. At the moment, our scripts are starting to swell, and we're gonna run into trouble if we try to keep everything in one single script. So it's time to set up a state machine. Let's get started. All right, so first off, we need a little organization here, so let's make some folders. I'm gonna make one for scripts, one for animations, and finally, let's make one for our sprites. Now inside of our scripts folder, we're gonna create another folder called states. And then we're actually just gonna open up the patrol state. Now we're going to be keeping pretty much all this code, but we're gonna sort of cannibalize it out into other state scripts. However, this script is gonna become our main enemy controller. So let's rename the class enemy, then right click, and under quick actions, you can select rename file to enemy CS. This will make sure that Unity and the script itself share the same name. Okay, so what exactly is this gonna look like? Well, we've got our enemy state now. This is what's gonna sit on our enemy object, and it's what will have the logic for what state we should be in, and it will also share variables that the entire state is going to need. And so if we go into our states folder though, we're going to first of all create a C# script. We're gonna call this one enemy base state. This will be the base state that is sort of a template for the other states, and it will sometimes hold information the other states are going to need. However, we're also gonna need individual states. So let's create a C# script. This is going to be our new patrol state, and we'll move a bunch of our logic from our enemy state into here eventually. And then finally, for now, we'll create a last C# script, and this one is going to be our player detected state. Let's open up all three of these. All right, so as I said before, our enemy state will be the mono behavior. It's the state that will actually be on our enemy and will control which state they're currently in. Now for it to work, it needs to talk to our other scripts. We're gonna make a public enemy base state reference. We're actually gonna call this current state. And essentially this will work that enemy will constantly be telling enemy base state to run, but it will have different functionality depending on which state you're currently in, as it's only going to be a template and have very little code itself. So for that to work, we're going to need references to each of our states. So we'll make a public patrol state, and we're just going to call this patrol state. And then we'll also need to make one for our player detected state. All right, so now we're setting up a bit of a hierarchy where the enemy class talks to our enemy base state and tells it which specific state it's going to be acting as. Let's head to our base state for a moment. So we can get rid of our start and update methods for now. And essentially, this is not going to be a mono behavior anymore. Enemy base state will actually be more of a utility script that just runs in the background. We won't actually be putting it on an object. Now our patrol state then, it's not going to be mono behavior either. Instead, it is going to inherit from the enemy base state. So any script that we declare here in the enemy base state will actually be available to its substates. Let's head over to player detected and do the same. So beyond simplifying things, why exactly are we setting it up like this? Well, part of the beauty is that now in our enemy base state, if we have a variable, we're gonna make a protected enemy, and we're gonna call it enemy. Our state will have the power to talk to that variable without having to do references and get component calls and that sort of thing in order to do it. Now there's, for the moment, just two variables our enemy base state is going to want to make available to its substates. One is going to be the enemy script, and the other is going to be a protected string variable, and we're going to call this animation name. And we haven't set that up yet, but essentially it'll just make sure that we play the correct animation when we enter a new state, and it will also help the states to keep track of where they are. That'll make a little more sense as we get going. Now, we can't do too much in these states until we set things up in enemy, so let's head on over there. So we're going to take a second right now, and we're actually going to add an awake method here. And here we need to initialize each of these states. Remember, these are not mono behaviors, so we don't have a different script on every enemy. Instead, what we'll need to do is have each enemy initialize his own states. So I'll start by typing in patrol state is equal to new patrol state, and then we're just going to pass two arguments in here. Remember, there's two variables that we need, and so we'll pass each of those. Now the enemy script is the script that we're in right now, so we can just type this. And then we need to give this animation a name. we'll call this one patrol. Now similarly, we'll make the player detected state equal to a new player detected state. And again, we'll pass in this, and then we'll just call this animation bool player detected. All right, I hate red squiggly, so let's head to our enemy base state. And what we're going to do here is we're going to create something called a constructor. A constructor sort of gives identity and structure to a script, and so each time we initialize enemy base state, it's going to need to get the information from its own enemy. If we have 50 enemies, we'll need to have 50 different pieces of information coming in because it'll be different enemy scripts they need to talk to, and they could all be in different states. So the way we handle that is through a constructor called public enemy base state. You'll notice the name is exactly the same as the script itself. And we just tell it what information it's going to receive. It's going to get an enemy, which we'll call enemy, and it's also going to get a string called animation name. Now down here in our brackets, all we're going to do is just let this script know that its version of enemy, so this dot enemy, is equal to whichever enemy just got passed in, and this animation name is equal to the animation name that just got passed in. So this allows us to have different versions of enemy base state for every enemy in our game. All right, now we're almost ready to start separating out our concerns, but if I go back to enemy, you'll notice there's still those red squigglies. And that's because patrol state and player detected state aren't properly set up yet. And what we're actually going to do is we're going to borrow this constructor here. I'll head to patrol state. I'm going to paste it in. We just need to make sure that the name matches. So this one will be patrol state. Now, one last thing is just we need to actually make a reference here to our base. And it's just going to be the name of the variables that we just passed in. Now you'll notice here that this time around, I'm not filling in the information inside of the constructor in order to set the values of the variables. And that's what we're actually doing here with this base part. Essentially, it's saying, look at the base, the enemy base state, and just take its enemy and animation name to fill in those variables. So it'll save us a little time, and it just does everything immediately upon initialization. I'm just going to copy this one now, head to player detected state, where we can also remove these methods. We'll paste in the constructor, make sure the names match. And now when we go back to our enemy, our initializations are working. Now we aren't ready to test anything just yet, but if you pop back into Unity, your console should be error-free at this point. If for some reason you are getting errors, it could be because Unity doesn't love it when we rename scripts. So just make sure that the name of your script and the class name actually match each other. And that probably should take care of the problem. All right, so let's start actually making something happen here. So first off, in our awake method, once we've initialized our states, we're ready to actually tell them to run. So first of all, we're going to get this current state, which remember is just our variable for the enemy base state. We're going to tell it what we want to be our initial state. In my case, I want it to be the patrol state. We're then going to say current state dot enter. Now this is a method that doesn't exist yet, but essentially this will be like an awake method for each of our states. It'll make it run logic that we want it to do immediately when we enter a new state. Now to make this work better, we're going to have to head to our enemy base state. Now because this isn't a mono behavior, we can't do things like having an update method. You'll notice it didn't even recognize that. That's because update and other methods like it run using game time. And so if there's no object in the game, we can't use them. And so we're going to have to create some virtual methods here. And so first of all, let's create a public virtual void. So this is a lot like a public void. We'll call this one enter. The difference here, though, is that it's virtual, which means that our states are actually going to be able to override it and make it do things, which I'll explain a little more in a moment. But for the moment, let's just do a little debug here. So debug.log, and now we're going to take use of that animation name string that we sent in. So we'll say entered plus animation name. And so now when we start the game, it should run enter, and we should be able to see entered patrol state. Now we'll test that in a second, but at this moment, it's not going to quite be ready yet. So for now, we're just going to add a few more of these virtual void methods. We're going to make one for our update, but remember, we can't just call it update as this is not a mono behavior. So what we'll do instead is a sort of cheat. We're going to call this logic update. Then in a moment, we'll make it so that our enemy state actually calls this in its update and allows us to make a little loophole. We'll also make a public virtual void called physics update, and this will be a lot like our fixed update. So then if we pop on over into our enemy script, in our update, we'll just tell the current state to run that logic update method. Similarly, in fixed update, we'll just make it constantly tell our current state to run its physics update. This allows our states to kind of have monobehavior functions without being monobehaviors. Next, let's head over to our patrol state. And we're just going to do a quick action here. We're going to generate overrides. We can then pick which of the overrides we want. We'll do enter, logic, and physics update. And it'll automatically populate those for us. You'll notice that these have the keyword base, and that just means that they're linking back to the base script, the enemy base state, and that they will override those methods. That's why we have the keyword override in our method names. Let's do the same thing for player detected. We'll just right click, generate overrides, and pick the ones you want. All right, we're about ready to run a test, but first I'm just going to pop into enemy quickly. And I just want to head down here to where we have our player detected state. Right now I'm running a debug log charge, and I don't want that clogging up my console, so I'm just going to delete that for now. Okay, with that done, as soon as you start your game, you should see entered patrol, so we know our states are initializing, and your enemies should just be behaving as normal, which doesn't have anything to do with our state system. That's just our old script still running, but the patrol part's what we're looking for. All right, I know that was a lot of setup, but we're now in a great position to be able to add new states and actually get our 2 current states running. So let's head down to our update method. First of all, we do not want all of our states to always be checking for obstacles and for the player. We only want the states that actually need to do that. So we're going to cut those out. I'm just going to pop over to patrol state, as our patrol state will always want to check those 2 things. So we can go to logic update, paste them in there. And it's not going to like that because these methods exist in the enemy class. However, we have a reference to that thanks to our base line here. So we can just go enemy dot, and it won't like that, don't worry, and enemy dot. And now we'll be able to talk to those scripts, except that in enemy, you'll notice that these are just void. They're not public. So we're just going to make our check for obstacles a public method, and same for check for player. That'll clear up the problems there. Now there's a couple other little things that we want our patrol state to do. So let's pop back over to enemy again. And so we're actually going to go to our physics update now. And all of this movement here, we're not always going to want to move. So let's cut out this if-else statement. We can get rid of if player detected for now. So let's go to patrol state, head to our physics update, and paste that information in there. Now, it's a little annoying, but we will have to add our enemy in front of these lines, if enemy.facingRight. So in order to talk to all of these variables, we'll have to put the enemy prefix in front. So enemy.rb, enemy.speed, and etc. Now down here on this speed, don't forget to keep that negative sign. It'll go in front of enemy. Otherwise, he'll always go in the same direction. Now at the moment, we're just having a problem with our facing right variable. But if you pop back over into enemy and we find facing right, we just want to make sure that this becomes a public bool. And at this point, I'm actually going to grab player detected and just going to move it down below so that we're keeping all of our public variables together and our private ones separate. All right, we're getting close at this point. However, there's a little bit of logic left to happen. We don't just want to check for obstacles in player. We actually want something to happen if we find them. So let's create an if statement here. And so we're going to say if enemy.checkForObstacles, then we actually want something to happen. In this case, what's going to happen is if there's an obstacle, we want to rotate our enemy. And so I could call the rotate enemy.rotate. However, rotate is going to be specific to our patrol state. And so let's pop over to enemy here, go down to the bottom where we can grab our rotate method, and I'm just going to cut it right out of here. We can then head back to patrol state, and let's just add it down at the bottom below all of our overrides. And again, of course, we'll have to add the enemy lines. And don't forget to keep your exclamation mark there. So now if enemy.checkForObstacles, we're going to rotate. Now, again, a little problem here because this is not a true-false statement. It is actually a method. And so we're going to just make a little change in our enemy script. So let's pop back over there. If we look at check for obstacles, what we want to do here now is instead of it being a public void, we're going to make this a public bool. So essentially now this is just a calculation trying to figure out a true-false value for obstacles. So if we hit a collider or an obstacle, instead of rotating, we're just going to return true. So when we call check for obstacles now from the patrol state, if we see one, we'll return true. However, we're going to need an else statement. So if we don't hit anything, we need to return false. You'll notice that got rid of our errors here. Now we go to patrol state. So it's always going to check when we're in this state for an obstacle. If it returns a true value, it will rotate. Now, because we're going to get our check for player, and we actually want check for player to have more precedence than check for obstacles. And so at the top here, let's make an if, and then we'll put enemy, check for player. And now if we see the player, we actually want to switch states. We want to go to our player detected state. So we're going to go enemy dot, and we're going to create a new method, which we'll have in a second, called switch state. And the state we want to go to is our enemy dot player detected state. Now we're just going to have to fix this, so let's pop over to enemy. Now first off, like we did for obstacles, we're going to turn our check for player into a bool. And so now if we hit the player, instead of running a coroutine, we would return true. And we can get rid of this if part. And essentially just if we don't hit the player, we can return false. All right, so the one other thing we need to do, if you look in our patrol state, is we need to create this switch state method. So again, let's go to enemy. And while it may feel like our enemy state's getting a little crazy at the moment, it's actually organized pretty carefully. At the top here, I'm just going to quickly create a region called variables for now. And then at the bottom of that, we will hashtag end the region. What this does is creates the ability to hit this little minus and close it up. I'm going to create another region, and this will be our Unity callbacks. By the way, thanks to Bardent for this idea here. He's the one who showed this to me and super duper helpful. We're then going to have our hashtag region, and we'll call this one checks. And then at the bottom of this, we can go end region. And for now, I'm going to go hashtag region, and we'll just call other functions, and we'll put our gizmos in there. And we're not going to be hanging on to these quite in the same capacity, so I'm just going to leave them out for the moment. Now, here in our other functions is where we're going to create our switch state. So let's go public switch state, and sorry, it should be a void state. And we're going to have to pass in an argument. We need to pass in a type of base state. So we'll go enemy base state, and we'll just call this new state. So whenever we call this, we'll pass along a state. Remember, all our states derive from this base state, and it will set that up as our new state. So essentially, when our patrol state wants us to switch, it's going to pass along player detected state. This will receive that information, and it will now say that our current state is equal to that new state that just got passed along. And then what we're going to do is we're going to call the current state dot enter method. So whatever we want to happen at the start of that new state, so in patrol, we actually don't have anything in there yet, but often we'll have something that happens right at the start of a new state. The one other thing I want to do here is before we declare the new state, I want to make another one called current state dot exit. And this is just going to set us up for later, as sometimes we're going to want specific logic to run when we leave a state. So let's go to our enemy base state, and right after enter, let's make the public virtual void called exit. Now we don't need to add this to our patrol state as it won't make use of it, but a little bit later we'll add it to the player detected state. So now, whenever we change states, we'll call exit on the current state, we'll set our current state to the new state, and then call the enter method on our new state. Let's do a quick check now just to make sure that everything's working as it should. So just go File and make sure to hit Save All. At this point, when you play your game, your enemy should be patrolling as normal. We should get our entered patrol state. However, right now, if we actually run over there and get in his way, he's going to stop patrolling. You'll see that he entered his player detected, but because there's no logic there, his momentum just kept carrying him right out of the scene. So let's set up our player detected state now. So in here, there's a couple of things we're going to want to do. First of all, let's go back to our enemy state. And we're going to handle a lot of this logic now inside of our player detected state. So let's actually grab all of this, and we can get rid of that coroutine at this point. For now, let's just paste it into our enter. So let's do a quick check here. First of all, this player detected variable is actually not doing anything, so we can get rid of that. And we do want our velocity to be set to 0, so he pauses right away. So let's go enemy.rb. And we are also going to want to play our alert. So we can go enemy.alert set active. Excellent. The one other thing we'll want to do is grab our exit things. Let's get rid of that coroutine now. Head over to detected state. And these are going to want to happen in our exit method. So we could just write that in public override void exit. And it would help if you can spell override. Let's paste those in there. Again, player detected isn't actually doing anything. And we'll make our enemy.alert set active false. Okay, we're actually almost done this state. You can already see how easy it is to set up new states now that we've got this state machine set up. Let's head down to our logic update, and here we just want to always check for a player. Essentially, if he doesn't detect the player, we want to leave this state. And we just want to call our enemy.switchState, and it's going to change it to enemy.patrolState. So he'll go right back to his patrol state at that point. Okay, let's go File, Save All, and let's test this out. Now I'm just getting a little error warning here telling me player detected is assigned but never used. And if I follow that error and open it up, I've just still got this player detected. It's gray because we're not using it, and so we can just delete that at this point. All right, so at this point we should be patrolling just fine. And when we switch to our game view and we run over and we get in front of him, he should be doing his player detected. Excellent. We're getting our pop-up, and now if I leave, he goes back to patrolling. All right, everything's working as it should, and now we've got a great state machine system so that we can easily add new states. Next video, we'll look at adding a charge state, and then we'll also get some damage happening. Hope to see you in those videos. Until next time, this is Matt with Night Run Studio. Cheers.